Have you ever listened to an argument and just had that feeling, that something's not quite right, but you can't put your finger on it? Well, today, we're putting on our detective hats. We're going to learn a foolproof method to investigate any argument and expose its flaws.
So that's the big question, right? How do you go from just a gut feeling to actual proof? How can you show with a 100% certainty that a line of reasoning is just broken? That's exactly the mystery we're going to solve.
Our investigation really starts with one key idea, this quest for what's called validity. In the world of logic, that word has a super specific meaning, and it's the gold standard we're hunting for.
And here's what it is. A valid argument is like a watertight contract. If you accept all the starting points, we call those the premises, as true, then the conclusion has to be true. It's an absolute guarantee.
So that sets up our mission perfectly. As logic detectives, we don't need to prove an argument is wrong all the time. Nope. All we have to do is find one single scenario where the premises are all true, but the conclusion ends up false. If we find that one crack, we've broken the case wide open.
Okay, every detective needs a case file, so let's open ours up and take a look at the argument we're going to be investigating today. It's time to decode the clues.
Now, I know what you're thinking. These symbols might look a little intense, like something out of a math class, but don't worry about it. Just think of them as shorthand. We've got a set of clues, our premises, and a proposed solution, the conclusion. Our job is to figure out if those clues really lead to that solution.
All right, let's break down this case. We have 3 clues. Premise 1 says, either P is true or Q is true. Pretty simple. Premise 2 says, if P is true, then Q has to be false. And our third clue, if P is true, then R must also be true. So the argument is claiming that with these 3 clues, the only possible outcome is that R is true. But is that right? Our job is to see if there's any loophole.
Now, to test this thing properly, we need a special tool. For a logic detective, the ultimate gadget is the truth table. It lets us check out every single possibility, no guesswork involved. And building it is just a simple step-by-step process. First, we list our basic variables, P, Q, and R. Then we make a column for each of our 3 premises, our clues. And finally, one last column for the conclusion. This whole setup is going to let us see everything all at once.
So here's our framework. Each one of these rows is like a different what-if scenario. It represents every possible combination of P, Q, and R being true or false. Since we've got 3 variables, that means there are 8 possible worlds we need to investigate. Now, let's fill this thing in.
Okay, the table's built. Now for the interrogation phase. We've got all the evidence laid out, and we're going to scan it, looking for any inconsistency, any crack in the logic.
And here it is, the completed table. Every possibility is calculated. So now, the hunt begins. We're looking for that one specific pattern, the one thing that can bring this entire argument crashing down.
This is what we're looking for. It's called a critical row. Think of it as our smoking gun. We're looking for a single line in this whole table where every single premise column is true, but the conclusion column is false. Does a row like that even exist?
And yep, there it is. Look at that 6th row. In this one specific scenario, premise 1 is true, premise 2 is true, premise 3 is true. All the clues check out perfectly, but look at the conclusion. It's false. This is the fatal flaw we were searching for.
So let's just zoom in on that row. This is our counterexample. It describes a totally possible world where P is false, Q is true, and R is false. And in that world, all of our starting clues hold up, but the conclusion they lead to fails completely. The logical chain is broken.
So, based on this undeniable piece of evidence, we are now ready to deliver our final verdict. The case is officially closed.
You see, that one row we found isn't just a random fluke. It represents a real, possible scenario where everything the argument starts with is true, but the conclusion it tries to force on us is actually false. And that, right there, is the whole point. It doesn't matter if some of the other rows looked fine. The fact that we found even one critical row, one counterexample, proves that the conclusion isn't guaranteed. And that means the argument is invalid. Case closed. So, now you've got the tool and you know the technique. You're ready to be a logic detective in your own life. Keep your eyes and ears open, because now you know exactly what that fatal flaw looks like. So what flawed arguments will you spot today?